In part 2 of our finding inverse trig functions videos, we're going to look at actually evaluating these. But before we go into trig functions, I want to go back to square roots. When I think about square roots, let's look just at the square root of 16. We all know deep down in our hearts that the square root of 16 is 4. That's the answer that we give, that's the answer that we use. But when we're dealing with square roots, there's always this pesky other value, that -4 that's kind of floating around in our head, and we use them at certain times and we don't use them at other times. That's because, long and short of it, we call this 4 the principal value. And depending on the situation, we'll use the principal value or we'll go to the other value. But the principal value is the one that we all agree upon as the value we're going to use in most normal situations, if I don't want to get too mathematical with it. But there's also these other answers lurking around. And that's going to translate really well to our idea of trig functions, because we know with trig functions and coterminal angles and all of that, that there's going to be lots and lots of answers to things. So we have to agree on what we're going to call the principal value. So when we're evaluating, when we're actually getting the angles from these inverse trig functions, we need to know where to look for the principal values. How do we know which one is the value we're going to use? So, first example, we have the sine inverse of -1/2. And remember what we talked about before. I've been given a ratio of sides, and it's asking for an angle. Specifically, it's asking me for what angle has a sine of -1/2. So let's go to my unit circle. If you look at your unit circle and look at all of the different values, then you're going to find there are two possibilities. If I take the sine of 210 degrees, I get -1/2. And 330 degrees, I get -1/2. So the question is, who is my principal value? Which one am I going to take and call my inverse value? Which one would the calculator give me? And I'm going to tell you right now, if you put it into the calculator, the sine inverse of -1/2, you're going to get 330 degrees. So the question is why? Why is it 330, and how do we know which one to choose? So let's go ahead and let's make a little chart. The chart's going to help us a lot. It's based on the quadrants 1, 2, 3, and 4. Now I'm just going to give you these where the different inverse functions are going to be for sine, cosine, and tangent, and we can develop the idea later in class as to why it's this way. It's based on the graphs of the trig functions and their inverses. But for now, let's just say if I have sine inverse or tangent inverse, I'm going to be looking at quadrants 1 or 4. Which makes sense why we chose 330 degrees, because he was right there. He was defined in quadrant 4 for the inverse sine function. So sine or tangent, they're going to go together in 1 or 4, and that leaves my other guy, cosine, and he's going to be defined in quadrants 1 and 2 for the cosine inverse. So just kind of learn those, use those. We're going to take this picture and use it a lot. And again, I said I can explain as to why this is looking at the graphs a little bit later. For right now, sine and tangent, 1 and 4, cosine, 1 and 2, when we're talking about their inverses. So I put this little picture over here so that we can use it. We're going to use that a lot to know where to look for our principal value. So for 3 examples here, we're going to find the exact value of the following. And by exact, what I really mean is, I still mean special triangle. That's what we've always done with exact, which means I can use my unit circle. But now it also means principal value. I'm going to be looking for that principal value. So first example, I have the sine inverse of √2/2. And remember, I'm going to write this all the time. Eventually, I'll hopefully get away from it. This is asking what angle, and now we can actually say what quadrant he's in. Since it's a positive sign is going to be in quadrant 1. So my question is, what angle in quadrant 1 has a sine of root 2 over 2. So I just refined my question, and I added this part right here as to where to look. So sine inverse of root 2 over 2, I look at quadrant 1. The only value that has a sine of root 2 over 2 is going to be 45 degrees. Or I could say pi over 4. Example 2. Let's say I have the arc cosine of -1. So now I refine my question a little bit. I'm thinking, what angle? And my question is going to be in quadrant. Well, if I look for cosine right there, cosine is going to be negative in quadrant 2. So I'm going to say what angle. The word in is kind of loose here, but in quadrant 2, or near, is going to be a little different. In quadrant 2 has a cosine of -1. It's telling me where to look. So if I look, and in this case, he's a little different because cosines and 1s and -1s should make me think quadrantal. I have -1 comma 0, which is cosine comma sine. Cosine sine. So my answer is going to be 180 degrees because it's a quadrantal. And the cosine of 180 is -1. And he is, quote unquote, in quadrant 2. My third example, my last one, we're going to expand things a little bit here. And we're going to deal with one of the functions we haven't looked at yet. So what if I have the cosecant inverse of -2? Cosecant. What I need to do in my head is two things. First thing, I need to think like this. I need to think, this is really giving me, use a bracket, this is giving me cosecant inverse of -2 over 1. Now, why is that important? Remember, with inverse trig functions, this is a ratio. It's a ratio of sides. Specifically for cosecant, I have hypotenuse divided by opposite. So if I want to go from cosecant to somebody I can deal a little easier with, his friend is sine. But I have to remember, if I'm dealing with sine, my ratio isn't hypotenuse over opposite, it is opposite over hypotenuse. So this is going to become opposite 1 over 2. And I can put the negative out front. He can move around. So just so we're clear, I just flipped or took the reciprocal. Oh, let me back up. It's OH. Opposite over hypotenuse. I took the reciprocal of cosecant in order to move to sine. I moved to sine because he's a lot easier to deal with. So I have sine of a negative, sine inverse of a negative, so I'm looking at quadrant 4. So my question has become, what angle in quadrant 4 has a sine of -1/2? That's the question I'm looking for in order to answer my original cosecant inverse. So if I look at my unit circle, let me scroll down just a little bit and erase a little. Look at my unit circle. To answer this question, I end up getting 330 degrees. Or I could say 11 pi over 6. So I go way back and say the cosecant inverse of -2 equals 330 degrees. Or I could say it equals 11 pi over 6. So if I'm dealing with one of my reciprocal functions, I change it over into sine or cosine because it's easier to deal with. And then I just find the value from that. So there's 3 quick examples on how to find these. In the next video, I'm going to go through and just do some examples from what's going to be the homework or the classwork, and show you how to find those using a calculator and how to find inverse trig functions of things like tangent and using some reference triangles.